Boltzmann Brain explained. What if your most cherished memory, the one that defines who you are, never actually happened? What if the warmth of your first love, the pride of your graduation, the sting of your first scraped knee? What if all of it, your entire tapestry of a past, was nothing more than a random cosmic glitch? A set of files loaded into a mind that flickered into existence just a moment ago. This isn't the premise of a science fiction movie. This is a terrifying possibility that arises from the fundamental laws of physics, a thought experiment so profound it keeps cosmologists up at night. It's called the Boltzmann Brain hypothesis, and it suggests that your entire reality, your very existence, might be the most elaborate lie in the universe. To understand this cosmic nightmare, we have to start with a concept you might remember from science class: entropy. It's often described as a measure of disorder or randomness. The second law of thermodynamics, one of the most unshakable laws in all of physics, states that the total entropy of an isolated system can only increase over time. Think of your bedroom. It's easy for it to go from clean and ordered to messy and disordered. It takes energy and effort to reverse that. A shattered glass doesn't spontaneously reassemble itself. An ice cube in a warm room doesn't get colder. It melts, its ordered crystal structure dissolving into the random motion of liquid water molecules. The universe itself follows this rule. It began in an incredibly low entropy state, the hot, dense, highly ordered singularity of the Big Bang, and has been expanding, cooling, and getting more disordered ever since. The ultimate fate of our universe, according to many models, is a state of maximum entropy known as heat death. This is a future so distant it's almost unimaginable. A universe that is vast, cold, dark, and almost perfectly uniform. All the stars have burned out, black holes have evaporated, and all that's left is a thin, featureless soup of particles floating aimlessly in an endless void. It is the ultimate state of disorder. But here is where the genius of 19th century physicist Ludwig Boltzmann comes in, and where our nightmare begins. Boltzmann, a pioneer of statistical mechanics, understood that the second law of thermodynamics is a statistical law, not an absolute one. In a system with countless particles randomly bouncing around, it's not impossible for them to briefly arrange themselves into a more ordered state. It's just mind-bogglingly improbable. Imagine a room filled with air molecules. It is statistically possible, though you would have to wait longer than the current age of the universe, for all the molecules to randomly zip over to one side of the room, leaving the other side in a perfect vacuum. The odds are against it, but they are not zero. Now let's apply this to the heat death universe. In this vast, boring equilibrium state, over trillions upon trillions of years and beyond, random fluctuations will still happen. A few particles might randomly assemble into something more complex for a fleeting moment before dissolving back into the void. And this is the core of the paradox. What is more likely to form from a random fluctuation? An entire, functioning, 13.8 billion-year-old universe with hundreds of billions of galaxies, each with hundreds of billions of stars, with a specific planet in a specific solar system that evolved life over billions of years to produce your specific brain? Or just your brain? The answer is terrifyingly simple. It is statistically, overwhelmingly, and indisputably more probable for a single conscious brain to spontaneously assemble out of the random chaos of the void. What's more likely? That you shake it and all the grains perfectly form a miniature, detailed sandcastle? Or that you shake it and a tiny, fleeting pattern of just 10 grains forms the shape of a star? The sandcastle is the universe. The tiny star pattern is the Boltzmann brain. The amount of order required to create an entire universe is exponentially greater than the amount of order required to create a single isolated mind. But here's the kicker. For this brain to be self-aware, for it to have a thought like "I exist," it needs a framework of reference. It needs memories. So the most common type of spontaneously formed brain wouldn't be a blank slate. It would be a brain that flickers into existence complete with a fully formed, internally consistent, yet utterly false set of memories. It would have memories of a life on a planet called Earth, of growing up, of learning about physics, of watching a video explaining the very paradox of its own existence. It would believe with every fiber of its being that it was the product of a long, coherent past. And then, a fraction of a second later, its improbable low-entropy state would dissolve and it would cease to exist, its brief, illusory consciousness vanishing back into the high-entropy chaos. This leads to the horrifying conclusion. If our universe is destined to last long enough to enter a state of heat death, it will spend an eternity producing these random fluctuations. Over these infinite timescales, it will produce an infinite number of Boltzmann brains. The number of these hallucinating, short-lived minds would vastly outnumber the real observers like us who evolved through the slow, traditional evolutionary process. Therefore, if you find yourself being a conscious observer, the laws of probability suggest that you are overwhelmingly more likely to be a Boltzmann brain than a product of the Big Bang. Your entire past is a lie. The world you see around you is a fabrication. The laws of physics you perceive are just part of the memory package. You are a cosmic fluke, a fleeting thought in a dead universe. And this isn't just a philosophical puzzle. It is a genuine crisis that strikes at the heart of cosmology, forcing physicists to question the very models they use to describe our reality.
Because if your best theory of the universe predicts that you shouldn't trust your own mind, you have a very big problem.
Physics nightmare and solutions. The Boltzmann brain isn't just a spooky campfire story for physicists, it's a fundamental threat to the scientific method itself. It represents what some call a cognitive instability. Science is built on a foundation of observation and evidence. We look at distant galaxies through telescopes. We measure the cosmic microwave background radiation. And from this data, we construct theories about the universe. But the Boltzmann brain hypothesis attacks this foundation at its root. If, statistically, any given observer is more likely to be a lone, hallucinating brain than a real person in a real universe, then all of our observations become suspect. The cosmic microwave background? It's not evidence for the Big Bang. It's just part of your preloaded memory packet. The Andromeda Galaxy? A beautiful but ultimately fake part of the simulation. Any scientific theory that predicts that Boltzmann brains should be common is, in effect, predicting that its own evidence is unreliable. The theory eats itself. This is why cosmologists consider it a nightmare. A successful model of the universe must predict that observers like us, who evolved over billions of years in a complex, structured cosmos, are the norm, not the exception. If a model ends up predicting a universe dominated by these phantom minds, it's thrown out as a bad theory, even if it explains other things well. This paradox also deeply distorts our understanding of time. We perceive a clear arrow of time because the past had lower entropy than the future. We can break an egg, but we can't unbreak it. We remember the past, but not the future. This is all tied to the universe evolving from the highly ordered Big Bang towards a disordered heat death. A Boltzmann brain completely violates this. It is a sudden, random, local in entropy, a tiny pocket of extreme order spontaneously appearing in a sea of maximum disorder. It would have memories of a low entropy past that never happened, and its own future would be a near instantaneous dissolution back into high entropy chaos. For a Boltzmann brain, the most likely moment in its existence is its very last, as it's poised to dissolve back into equilibrium. This means that if you are a Boltzmann brain, you are likely experiencing your final moment of consciousness. A chilling thought, to say the least. So, how do we escape this existential trap? How do physicists banish the Boltzmann brains from their theories and ensure that our reality is, in fact, real? The solutions are as mind-bending as the problem itself, pushing us to the absolute frontiers of theoretical physics. The most straightforward approach is to get rid of the conditions that create them. Boltzmann brains thrive in a universe that is eternal and eventually settles into a quiet, stable, high-entropy state. So, the first solution is to ensure our universe doesn't do that. It must have a definitive end, and that end must arrive before it has an eternity to cook up these phantom observers. One way this could happen is through a big crunch, where the expansion of the universe reverses and it collapses back in on itself. Another, more favored possibility in modern cosmology is the idea of vacuum instability. The idea here is that the vacuum of space, the seemingly empty void, might not be in its true lowest energy state. It could be a false vacuum, a metastable state, like a ball resting in a small dip on the side of a large hill. It's stable for now, but a sufficient jolt could send it tumbling down to its true ground state at the bottom. If this were to happen anywhere in our universe, this bubble of true vacuum would expand at the speed of light, destroying everything in its path. If our universe is destined to end this way, it will never reach the quiet equilibrium of heat death, neatly preventing the Boltzmann brain apocalypse. The universe would be finite in time, and the number of real observers would safely outnumber the phantom ones. Another escape route lies within the bizarre world of the multiverse. Many inflationary models of the early universe suggest that our Big Bang was not a one-time event. Instead, our universe is just one bubble in an eternally inflating multiverse that is constantly spawning new universes. This creates an infinite space and time, which seems like it would make the Boltzmann brain problem worse. However, it also introduces something called the measure problem. In an infinite multiverse, there are an infinite number of normal observers and an infinite number of Boltzmann brains. How do you compare two infinities? It's like asking, are there more even numbers or more whole numbers? The answer depends on how you count them, or your measure. Cosmologists are actively searching for a logical, non-arbitrary measure for the multiverse that naturally predicts that normal, evolved observers like us are vastly more common than spontaneously formed brains. While no consensus has been reached, it's a promising avenue that suggests the structure of the multiverse itself might save us from solipsism. The Boltzmann brain problem is a powerful reminder that our understanding of the cosmos is far from complete. It forces us to confront the deepest questions about existence. What is the relationship between mind and matter, between entropy and time, between probability and reality? The fact that physicists take this seemingly absurd idea so seriously is a testament to their intellectual honesty. They are willing to follow the logic of their theories, even when it leads to conclusions that threaten to undermine everything. The quest to solve the Boltzmann brain paradox is more than just an academic exercise. It's a search for a coherent narrative of our universe, one in which our lives, our memories, and our discoveries are meaningful parts of a real evolving cosmos. So, the next time you look up at the night sky or recall a precious memory, take a moment.
The fact that you can even ask the question, "Am I real?" is at the heart of the mystery. The universe has not yet given us a definitive answer, but the search itself is what drives science forward, deeper into the beautiful, terrifying, and profound nature of reality.